Okay, this is part of your independent study. This is something that would typically take 2 classes to teach, so I'll have it broken up into 2 parts. 11.1 Permutations. Open up your textbook, page 5116, and jot down the title, 11.1 Permutations. Permutation is an arrangement where order is important. But to get a little more meaning to this, I want you to pause the video after this and turn to page 516 and read the introduction here, just so that you understand the kinds of problems that are permutations. I'll assume you're pausing and reading now. Okay, you've read it. Now, let's think about this. Are the following permutations? In other words, is order important? Now, the numbers drawn for Lotto 649. What is Lotto 649? You might not know because you're actually not at the legal age to buy lottery tickets maybe, but it's a draw where you have to match, you pick 6 numbers, and it has to match the 6 numbers that are drawn, and the only numbers you can pick from are 1 through 49. Now, think about this. I'll show you a little video here of the actual Lotto 649 numbers being drawn here, and it might make more sense here. As you can see there's the little totally random. You can see there's a machine that just pulls the numbers out, and just take a look there. What was that here backwards? 31, 15, 1, 27, 3, 36. Now, those are the numbers that they were drawn. They don't have to be in any particular order just from that. The 6 winning numbers, it doesn't matter if you had the 15 first and then the 31. The order is not important. That's what you need to know out of that. So since order is not important, it's not a permutation. Now, not a permutation, because that's what was asked. Why? Because order is not important. Run out of space here. That's what you got to look for, because you got to decide if questions are permutations or not. It especially is important in section 11.2, where you got a couple of types of problems. The top 3 runners in a competitive race. Now, is order important there? I'd say yes, because if you came in first, and that's Bill, second is Susie, third is Pete. Order is important, because if I listed Pete's name first, that'd be a totally different outcome, right? So when you're talking about something that's ranked, order is important. That's a permutation. So this is a permutation. Order is important. Now, I get you to write something down, so maybe pause the video, jot this down, and we'll talk about it. Now, I'm assuming you've jotted this down. Let's read through it. Fundamental counting principle. The AND rule. AND is the key word here. If one task can be performed in a number of ways, and a second task can be performed in B number of ways, then the 2 tasks can be performed in A times B ways. You multiply when you can use the word and typically. It means they're both happening. Now, once again, pause the video and write out in your notebook, because you're going to want really good notes. Example 1 from page 518 in your turn. I'll show you what I mean too here. You're not sure here. 518. First of all, there's example 1. I'm not doing that. I'm doing the what follows. You should probably read through this either before or after we do this example here for your turn. But Right after example 1, there's your turn 1, I'm calling this. It's at the bottom of the page here. This is what we're going to do, okay? So take the time to jot this down, and then there's sort of a parallel question worked above here in more detail that you can go through on your own time. So, I'm assuming you've paused now. You've got this problem written out. Let's work through it, see what we can do with this. Now, do we understand the problem? A, how many 3-digit numbers can you make using the numbers 1, 2, 3, 4, and 5? Repetition is not allowed. So, when I see here repetition is not allowed, it means like 222 is not a possibility. Okay. But, what had already done B? Hey. 3-digit numbers, I've got 3 spaces to fill. I need a first number, and I need to pick the second number, and I need to pick the third number. I can choose from 1, 2, 3, 4, and 5 for these numbers. So that means for the first number in here, how many choices do I have? I have 5 numbers to choose from. Now, for the second number, since I can't repeat it, I'm down to 4 numbers to choose from. For example, if I had picked 3 as my first number, I can no longer use that. I'm down to 1, 2, 4, and 5. That's why I have 4 digits left. Likewise, I've used up a second digit when I placed a number in number 2. So now I'm down to 3 digits to choose from. Overall, to solve A, how many 3-digit numbers? 5 times 4 times 3. That's 20 times 3, it's 60. You should be able to do these problems without a calculator. So you could write a sentence down. 60 ways to make 3-digit numbers without repetition. Now, change. B changes things up a bit. How does the application of the fundamental counting principle in part A change if the repetition of digits is allowed? Well, the fundamental counting principle is multiply each time if it's an AND situation. Now, 3-digit numbers, you need to pick a first and a second and a third. So it's still multiplication. Something's going to be different though, because there's repetition allowed. Now something like 222 is allowed. So you ask yourself, how many choices for your first digit? I've got 5 choices, but because repetition's allowed, I still have 5 choices for my second digit, 5 choices for my third digit. You should be able to multiply this out. 5 times 5 is 25, times another 5, 125. You should be able to do that without a calculator. Not saying that you have to, but you should be pretty nifty with numbers. Now, before we move on to the second example from your turn on page 520, I want to show you something here, because it's involving some kind of factorial notation, okay? So, take a second to jot down example 2, your turn, page 520. Also, you might want to read through example 2 that's worked out just before the your turn on page 520. Before we do much else though, factorial notation. Now, I'm assuming you've copied this down, you've paused the video if you needed to. First of all, factorial notation is this. Your calculator actually has a button for it. It could be like this, and factorial button, or a menu option. Some calculators have it like this, just the factorial button. But what it is, in factorial, well, I'll give you with an example here. If you have 5 factorial, that means 5 times 4 times 3 times 2 times 1. It's a countdown where you're multiplying. If you had n factorial, so whatever, that number could be 7, could be 1,000,000. These have to be positive numbers. It is that number, not factorial, I'm just rewriting that again. I'll try this again. N times the number below it. So how would you notate that? N minus 1 times the number below that. N minus 2 times dot, 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 all the way till you get to 1. You got to work it down till you get to 1. You see how that formula works? N minus 1 in that case was 4, n minus 2 was 3. And we went until we get down to the number 1. It's a countdown, okay? Now, there's also something else in here. It uses factorial notation. The permutation formula, and there's a permutation button on your calculator. You don't need to know how to use it, but you should see how the notation works. I'd like you to see that. So the permutation notation. How does that work? Well, you're going to see something like this, NPR. It might be one of your buttons in the math menu. It might be one of your options. What does that mean? You should know without the calculator what that means. That means take your n value, factorial, on the top, on the numerator. On the bottom, you take the difference between n and r, and that becomes your denominator, n minus r, factorial. And we'll see how that works right away with example A, okay? It might look complicated, but it really isn't that complicated. So A, evaluate 7p2 using factorial notation. 7p2. Okay, we're going to assume you're going to do this without a calculator, using factorial notation. So 7p2, that means the numerator is, keep in mind we're using this formula here, the numerator is the 7 factorial. I got all messed up with that blue there. The denominator is 7 minus 2 factorial on the, so 5. I don't need to put it in a bracket, but 7 minus 2 factorial on the bottom. That's where that came from. Okay, how are we going to evaluate this? I definitely, if I was doing this in my head, would not want to calculate out 7 times 6 times 5 times 4 times 3 times, okay, and you get it. You don't want to do that. So what does 7 factorial mean? It means 7 times 6 times 5, and so on, and down. So I could say n 5 factorial, because that's 5, 4, 3, 2, 1 multiplied. On the bottom, I have 5 factorial. Hey, you notice something? Identical numerator and denominator factors of 5 factorial. This isn't that hard to calculate after all. So, 42. Now this is an aside. I'm going to go back up to here. Example 1 could have been done with that permutation notation. What it really means is an application here is that if you have 1, 2, 3, 4, 5 things to choose from, and you want to pick 3 of them. So if I said 5p3, that's going to give me the same answer of 60. Why? Because we've got 5 factorial on the top, divided by 3 divided by 5 minus 3 on the top, so 2 factorial, You know that that simplifies to 5 times 4 times 3 times 2 factorial. 2 factorial on the bottom. And you definitely got the same thing there, 5, 4, 3. It'll come out to be 60 as well. That's just another method. That's what that formula is for. It's another way to organize your problems. It's better to work these out from first principles like we did though, okay? Back to this, B. A little bit of algebra for you on B. Solve for n if np2 equals 56. Now there's a few different ways to do this kind of problem. I'll show you one. np2 equals 56. Now, I know the answer is 56, but np2, what does that mean as far as the formula? So I'll work directly below it. Well, n factorial over n minus 2, the difference. Factorial. That's equal to 56. Now I'm going to left-right reverse this equation. It doesn't change anything. I just want my 56 on this side because it's not going to be expanded. But I know that n factorial can be written as n times the next number below it, so n minus 1, times the next number below that, n minus 2, and the next number below that, but hey, I'm going to notice something. N minus 2 factorial, all the numbers below that until you get to 1. And the denominator is n minus 2 factorial. Hopefully you see at this point you've got matching factors, n minus 2 factorial. That means you've got a quadratic equation to solve. So 56 is equal to n times n, so n squared, minus n. I sure hope you remember some things, how to factor, how to solve a quadratic. I'm going to get a 0 on the left because I want it to look like a quadratic that you can factor. N squared minus n minus 56. Sure hoping you can factor that in a heartbeat. N minus 8. N plus 7. You've got two solutions. You've got n equals positive 8. N equals negative 7. However, I'd mentioned this above here. Factorial notation only works for positive numbers. So we have to use the n equals positive 8 solution. The other one isn't a valid solution for our problem, okay? Now, we're going to do one more example and then we'll wait for the next day for the other one. Permutations with repeated elements. Write this down. I'll assume you pause the video and write this down. Okay. You've written it down. N factorial, A factorial, B factorial, C factorial on the denominator. Now, A is how many times one element is repeated, B is how many times the second element is repeated, and so on. You could have A, B, C, D, E, like many things repeated. Now, this is following the worked example. I'm only going to do A for repeating objects. How many 5-digit numbers can you make by arranging all of the digits of 17,171? Now, do you understand this? We're using all of the digits. So think of it this way. We have 1, 7, 1, 7. One here. We've got these 5 numbers. Do you see that the ones are all repeated? So what I mean is that if I trade these places here, that's not a different number. Likewise, if I trade places with the 7, that's not a different number. So what you're doing is, you're still figuring out, if you've got 5 objects, how many ways can you arrange them? So that's where 5 factorial comes in on the numerator. So you could think of it as 5, 4, 3, 2, 1, if you want to think of filling the blanks. We're going to put down 5 factorial. 5 ways to arrange 5 objects. However, the repeats. Let's talk about the ones first. There's a 1 here, there's a 1 there, 1 there. Trade around the 7s here and stuff. This is only one arrangement that I've been working with the whole time, right? The ones in any given arrangement, you have 3 ones to choose from for this one, 3 ones to choose from for the second one, 3 ones to choose from for the third one. You have 3 times 2 times 1 in any given arrangement. 3 factorial is how many times you're going to repeat the ones if you traded them all around. Likewise, there's 2 7s, so you have 2 factorial. That reflects that you've got this 7 and 7 or this 7 and 7 for a given arrangement. You're dividing out all the repeated ones. I'm showing different possibilities right now, right? That's what you're dividing here, okay? You could do this by first principles without a calculator, right? Because you know that this is 5 times 4 times 3 times 2 times 1, right? So 5 times 4 times 3 factorial divided by 3 factorial times, well, 2 factorial is 2 times 1, so 2. Let's see here. I can cross out 3 factorials. I can cross out a factor of 2, divide the 2 here. I've got 5 times 2 on the numerator. That's just 10 ways. When you take into account that there's repetitions. 1 is repeated 3 times. That's why we did this. The 7 is repeated 2 times. That's where that came from. Now, tomorrow we're going to talk about the fundamental counting principle, the OR rule, the other portion of this. And that's the second half. That's for I said tomorrow, whenever you get to this, for part 2, okay? You might want to try some problems relating to the first 3 examples that we did. It's your choice. I'll just stop the video and good luck.